This video, we're going to talk about 1.5 Objective 5, where we solve applications involving scientific notation. So a googol is defined as 1 followed by 100 zeros. So the first thing they want us to do is write that number in scientific notation, which is going to be 1 times 10 to the 100th power. Now you know where Google, the search engine, gets its names from, but it's spelled a little differently there. And a googolplex, which is what Google calls its headquarters. But again, you see that it's spelled differently there, is defined as 10 to the Google power. So this is going to be 10 to the 10 to the 100th power, like that. Very big number. So that's googolplex. A diameter is known of a known star is 3.2 times 10 to the 7th meters, and is about 170 times the diameter of a planet. It orbits, or that orbits it, excuse me, express the diameter of the planet in scientific notation. So we're going to take the 3.2 times 10 to the 7th meters and divide it by 170 here. And then 0.2 second EE7. We're going to take that and divide it by 170. And I've already set up my calculator to be in scientific notation, round to 1 decimal point. So this is 1.9 times 10 to the 5th. And then this is going to be in meters because we were in meters before and we haven't changed units. Computer can do an addition in 7.4 times 10 to the negative 15th seconds. How long does it take to perform 7.7 times 10 to the 6th addition? So 7.7 times 10 to the 6th divided by 7.4 times 10 to the negative 15th is going to be 7.7 second EE6 divided by 7.4 second EE negative 15. No, that's not right. Write this out with so this is additions. And then this is per 1 addition is going to be 7.4 times 10 to the negative 15th, and additions will go away. And this is seconds, so it's multiplication. So it is 7.7, it's this one right here. 7.7 second EE6, 7.4 second EE negative 15. And we get an answer that we're going to round to 1 decimal point is 5.7 times 10 to the negative 8th seconds. If it takes 0.057 seconds for GPS signal traveling at 2.998 times 10 to the 8th meters per second to reach the receiver in a car, find the distance from the receiver to the satellite. So D equals RT. So D equals the rate in meters per second times the time, 0.075 seconds. The seconds will cancel, left with meters, but that's going to be this operation right here, and 2.998 second EE8 times 0.075 is going to be, and then round to 1 decimal place, 2.2 times 10 to the 7th. And then this is going to be in meters because we are going for the distance here, meters. Right, 1 atomic mass unit, AMU, is 1.66 times 10 to the negative 27th kilograms. If 1 oxygen atom, it has 16 AMUs, an exact number. What is the mass of 328 million oxygen atoms? So 328, and I'm just going to say times 10 to the 6th atoms, oxygen atoms, times, and then 16 AMUs per oxygen atom, times 1 AMU is 1.66 times 10 to the negative 27th kilograms. So 328 million oxygen atoms times 16 AMUs per oxygen times, so it's this. So here we go. 328 times 10 to the 6th times 16 times 1.66 second EE negative 27. And we're to round to 2 decimal places. So 8.71 times 10 to the negative 18th. And these are going to be in kilograms. One more problem here. A couple more problems here. Microwave receiver circuit, the resistance of the wire, 1 meter long, is given by R equals K over D, where D is the diameter of the wire. Find R, K equals the number, and that's measured in ohms times square meters, and the diameter is that number. So K is 0.0000 2, 3, 4, 5, 6, 7. There. Let's write that in scientific notation. 1, 2, 3, 4, 5, 6, 7. So 2.194 times 10 to the negative 8th divided by D, which is 8.0 0.38 times 10 to the negative, it's going to be squared. 1, 2, 3, 4, 5. Okay. So numerator is going to be 2.194 second EE negative 8 divided by denominator is going to be 8.038 second EE negative 5, and that gets squared, and then close off the denominator, and this becomes 3 decimal places, so 3.396 ohms. And then a picture of a black hole was taken. The picture was of a massive black hole with a mass 2.7 billion times that of the sun. The mass of the sun is 2.0 times 10 to the 30th kilograms. Find the mass of the black hole. So 2.0 times 10 to the 30th times 2.7, and then billion is times 10 to the 9th. This was kilograms. So 2.0 second EE 30 times 2.7 second EE 9 is, and then we're going to use, yep, 2 significant digits here. So 5.4 times 10 to the 39th. Why do I say 2 significant digits? Because they showed that 0 there with the 2.0, so that makes that 0 significant. And then there's 2 significant digits here. So we want 2 significant digits in our answer. All right. Let's make sure that's it. Yes, that is it. So we'll come back next time and we will talk about one, I think we'll be on 1.6. Let me just check. We'll be on 1.5 objective 6 next time. We have one more objective in here in 1.5. So 1.5 objective 6. See you for the next video.